Alright, let's go on to the next part. Basically what I'd like to do is look at a measure that optometrists use to compare lenses and work out how they're going to combine lenses, essentially to correct vision defects, and it's called power. Now what we have is, if we have a convex lens, what a convex lens does is it focuses light. So light comes into it and it focuses or converges that light. When we have a concave lens, I'll just draw a concave lens here. A concave lens diverges light. So light that comes in refracts like this, refracts out, and diverges light. And the amount that each of these lenses diverge or converge, or just plain deviate the light, is related to the focus. So a focus that's really close for a convex lens will bend the light more, as opposed to one that's out here, focus further away. And likewise, I'll just change the colour. Now obviously the focus for a concave lens, the focus is a virtual focus, so it's on the opposite, like this light ray is coming as if it's from that focus on the other side, like that. But also, equally, the closer that focus is to the actual surface or the axis of symmetry of the lens determines how much that light is getting bent or deviated. Now the really interesting thing is, optometrists have a measure called power. Let me just take some of these things out of here. Yeah. Okay, alright, no problem. I didn't mean to take the lenses out, but never mind. I'll redraw them. Okay. Here's our convex lens. Here's our concave lens. Now the measure known as power is equal to, it's an equation that's equal to 1 over the focal length is power. And the really interesting thing is that with a convex lens, you have a power that's positive. And with a concave lens, you have a power that's negative. If you put two lenses in series together, and they've got the same power, obviously this one being a negative power and this one being a positive power, but if they're, I shouldn't say the same, if they're opposite, then the net effect is 0. So light will come in here, for example, bend away and diverge, and then converge the same amount, and the net effect, I haven't drawn that very well, but the net effect will be 0. These light rays here will be parallel to these light rays here, if that is, this value and this value are exactly the same magnitude but opposite. Now the really interesting thing is that optometrists have a good idea about what sort of power you need in order to focus things at a reasonable near point or at the far point. So they know the range, they essentially know the range of values for your eye in terms of power. So when you're looking at something in the distance, what should the power of your lens be? Or when you're looking at something that's very, very close, what should the power of your lens be? And then, by using a combination of either concave lenses like this or convex lenses in front of the eye, you can change this power value and then help the eye to focus either on things in the distance or things close by.